Hi friends, welcome you all. Today's topic is center tap full wave rectifier. Here we will understand the circuit diagram for center tap full wave rectifier, operation of circuit diagram during positive cycle, and also the operation of circuit diagram during the negative half cycle. Now let us start with what is the circuit diagram for center tap full wave rectifier. See, this is a circuit diagram. You can observe here there is a one center tap transformer is there. Two diodes are there which are facing towards right, and the connection of both the diodes is connected to one of the load resistor as shown in the circuit. Now we try to understand what is the operation of this center tap full wave rectifier, on starting with what is the role of this center tap transformer. Okay, let us observe this is a input waveform. This is a input waveform which are AC in nature because rectifier are used to convert AC to DC, especially AC to pulsating DC. So as a part of which this AC signal is fed to the transformer. Okay, you can see this, the voltage of this AC signal is V in. So V in voltage is fed to the primary winding of the transformer. Okay, this secondary winding of the transformer is tapped to ground at the center of the secondary winding. Okay, that's what this is called as a center tap transformer. Okay, as a part of which you can observe during positive cycle. Let us see this. During positive cycle, what happens? During positive cycle, this terminal becomes plus and this terminal becomes minus. So as a part of which this is center tap. Okay, due to which this plus and this to be observed as a minus. Okay, and simultaneously as it is minus, you will observe this part as a plus. So as a result of which this positive cycle will be taken positive only in the upper side of center tap. Okay, this positive cycle will be taken as a negative cycle in the lower side of the center tap. You can observe this secondary winding is tapped to ground exactly at the center, as a part of which the voltage which is V in at the input end will become V in by 2 at the output of the secondary transformer, above the center tap and below the center tap. You can observe here also it is V in by 2 because it is getting half. Main reason for the same is out this secondary winding is tapped center of the secondary winding is tapped to ground. That's the main reason why the voltage is getting half. Now during the same positive cycle, as it is getting positive cycle, so diode D1 is getting forward bias, and in the positive input cycle this lower side of the center tap is getting negative cycle, as a part of which D2 is becoming reverse bias. So this is what happening with respect to positive cycle of the input waveform. Now coming to the negative cycle of the input waveform, you can observe this negative cycle. Due to this negative cycle, this will be in the minus terminal, as a part of which this is plus terminal. It acts like a plus terminal above, and this will be plus because of negative terminal. Okay, as a part of which we can see here it will be minus. So due to which during negative cycle we will observe top of the secondary, winding, that is center tap. Above the center tap you are getting negative cycle, and below the center tap we are getting positive cycle, as a part of which diode D1 get reverse bias during input negative cycle, and diode D2 becomes forward bias during input negative cycle. Fine. So this is the operation of that operation of how the center tap transformer is working in this center tap full wave rectifier. Now we will see how the operation of center tap full wave rectifier during positive cycle and during negative cycle. You can observe due to this applied input voltage, so this above part of this center tap is acting like this, and below part of the center tap is acting with this waveform. So as a part of which during positive cycle diode D1 is getting on, as a result of which the current will flow like this. Okay, this is a direction of current during positive cycle of the input waveform. So it will not come here, this current whatever it is flowing, it will not come here to become a closed circuit, because this diode is off already. You can observe this negative cycle is applied here, as a part of it is as a part of which this diode is already off. So the only path for the current to flow is it has to pass through this RL and it has to ground. Okay, so this is during the positive cycle which diode is getting on, diode D1 is getting on and D2 is getting off, as a part of which the energy is flowing like this, and it is flowing from top of the RL to the down towards the down of the RL. So as a result of which, what is the waveform we will get here? What is the waveform we will get here? Across the RL, across the RL we are getting a positive cycle having peak amplitude as V in by 2, right? This peak amplitude of the positive cycle will be V in by 2. Okay, now we will see what happens during the negative cycle. During negative cycle, this diode already it is off, it is getting reverse bias, and during the same negative cycle the diode D2 is getting forward bias. Okay, because you can observe here during input negative cycle, so this is negative, this is getting positive. Okay, due to this negative diode D1 goes off, and due to this positive diode D2 got on. So as a result of which the energy flow during negative cycle will be like this. Energy flow during negative cycle will be following like this. So it will not go here, because this diode is already off, diode D1 is already off. So as a part of which the energy will flow or the current will flow like this. So due to which once again the energy is flowing from top of RL towards the down of the RL, or you can say current is flowing from top to the down of RL, as a result of which during negative input cycle we are getting a positive output cycle. What is the main reason? Main reason is simple. See, we are observing our output voltage across RL from top to down. Okay, from top to down for both the cases. You see, during positive cycle it is flowing from top to down like this. Okay, during negative cycle it is flowing like this. Okay, so during both the cycle the energy flow or the current flow through RL is always from top to down. So as a result of which during positive cycle also we are getting positive output waveform, during negative cycle also we are getting positive output waveform. So this is how the both the cycles, positive and negative cycles, are coming in a positive cycle, as a positive cycle at the output of the center tap full wave rectifier. Now we will understand the same concept with a good animation. I'm very much thankful for this animation. It's very interesting animation. So I hope all of you will enjoy this. So this is what happening in the positive half cycle. You can observe this. The energy is flowing through diode D1 and also it is flowing through RL. Means current is flowing from ground to ground. Okay. So this is how the current is flowing during positive half cycle of the input waveform. Okay, as a part of which you are getting output voltage like this. Okay, now we will move on to what happens during negative half cycle. So it is already mentioned, you can observe here D1 is getting forward bias, as a result of which it is closed circuit. D2 is getting reverse bias, as a result of which it is acting like a open circuit. Okay, in the same way we can observe what is happening during the negative half cycle also. Let us observe this. This is the way how the negative half cycle of the center tap full wave rectifier is operated. Okay, so this is very interesting thing. See, negative cycle is coming as a positive cycle during the output end, towards the output end. You can observe, please. So it's a very good animation. I'm very much thankful to this author who has animated this. Okay, I hope you enjoyed this animation and the way of explanation. Thank you for your patience listening. uh, I hope you like this video. Thank you. We will see in the next video. Thank you.